Section 2.7, Linear Inequalities and Absolute Value Inequalities. Using interval notation. Indicating the solution to an inequality such as x is greater than or equal to 4 can be achieved in several ways. We can use a number line as shown in Figure 2. The blue ray begins at x is equal to 4, and as indicated by an arrowhead, it continues to infinity, which illustrates that the solution set includes all numbers greater than or equal to 4. So you can write here positive infinity since it's going towards positive infinity. On the left side, it would be going towards negative infinity. Now we can use set Buehler notation, and we can say that x, this line such that x is greater than or equal to 4, meaning all the x's that are greater than or equal to 4. And again, translating it to all real numbers x, such that x is greater than or equal to 4. Now notice that the braces are used to indicate the set. Now the third method is interval notation, in which solution sets are indicated with parentheses or brackets. Now the solutions to x is greater than or equal to 4 are represented as bracket 4, comma, infinity. This perhaps the most useful method, as it applies to concepts studied later in this course and to other higher level math courses. Now the main concept to remember is that the parentheses represent solutions greater or less than the number, and brackets represent solutions that are greater than or equal to or less than or equal to the number. Use parentheses to represent infinity or negative infinity, since positive and negative infinity are not numbers in the usual sense of the word, and therefore cannot be equaled. A few examples of an interval or a set of numbers in which a solution falls are bracket -2, comma 6, or all numbers between -2 and 6, where you're including the -2 but not including 6. -1, 0 are all real numbers between, but they're not including -1 and 0. And negative infinity to 1 inclusive are all real numbers that are less than and including 1. Now table 1 outlines the possibilities. All real numbers between a and b, but not including a or b, is the set Buehler notation, which says x such that x is in between a and b, but it doesn't include a and b. The interval notation would both have parentheses at the end, a, comma, b. All real numbers greater than a, but not including a, you would have x such that x is greater than a. So you have parentheses at both ends because you're not including a, and you never include a bracket for an infinity, it's always a parenthesis. All real numbers less than b, but not including b, would be x such that x is less than b. So you're starting from negative infinity and going to b, and they both have parentheses. All real numbers greater than a, including a, would be x such that x is greater than or equal to a. Since we're including a, we have a bracket a, comma, infinity with parentheses. All real numbers less than b, including b, would be x such that x is less than or equal to b, which you'd have parentheses at negative infinity all the way to b with a bracket because you're including b. All real numbers between a and b, but including a, would be x such that x is greater than or equal to a and less than b. So you're including the a, but not including the b here. All real numbers a and b, including b, would be x such that x is greater than a and less than or equal to b. So the parentheses is around the a, comma, b with a bracket. All real numbers between a and b, including a and b, would be x such that x is greater than or equal to a and less than or equal to b, which means they both have brackets at both ends. All real numbers less than a or greater than b. So that would say that x such that x is less than a and x is greater than b. Since we have that and, we have to use the union symbol. So that means we go from negative infinity to a with parenthesis, union, comma, b to infinity. And then all real numbers, x such that x is all real numbers, goes from negative infinity to positive infinity, and you always use parentheses for infinity.